No engineer, no research scientist has as much freedom to create something from scratch as the developer of software. Even an architect designing a house has physical constraints. Wooden beams and concrete blocks, pipes and doors and windows all come in standard sizes. That's what the architect has to work with. David Fisher, a software specialist with the National Institute of Standards and Technology, says when he's writing software, he's only limited by his own imagination and by his ability to transform a particular task into instructions for a computer.
You don't have these constraints. Physical limitations are a non-issue. They just don't impact. The trouble is that freedom, that flexibility, that softness also probably undermines success.
That freedom allows programmers to produce towering skyscrapers of logic capable of doing amazing things, but the more complicated the programs, the more likely they are to contain hidden flaws. One of the biggest programs of all, the Empire State Building of software, is the telephone system.
When a person goes off hook, there's a signal that goes back to the office, and the hardware picks up that change of state.
Janice Sharpless of AT&T has written some of this software herself.
Then it alerts, like the central processor, with an interrupt, basically, that somebody went off hook, and the basic operating system then starts up a program that is yours and yours alone for that call. That's your property, so to speak.
Just putting a simple call through may involve 500,000 individual computer instructions. There are other programs that handle special features like call waiting or call return. Even more software is there to figure out what's happening when something goes wrong in the network. And then there's the software that allows a phone switch to work in foreign countries. It all adds up to 15 million lines of programming instructions, lines of code to run a single telephone switch. That's more lines than you'll find in a complete set of the Encyclopedia Britannica. Then, says Lee Stetcher, also of AT&T, consider that every telephone switch is constantly sending and receiving signals from other switches all around the world.
So you're talking tens of thousands of machines all communicating together, all themselves with stored program in them. And within a given machine, you're talking literally hundreds of microprocessors.
All of which means this system is too large and complicated for anyone to understand completely. Edsger Dijkstra, a pioneer in software development who teaches at the University of Texas, says at one telephone company, he won't say which one, programmers revised some of the software in their phone switch one day. The new software, they thought, meant another part of the program wasn't needed at all, so they took it out. But then, for reasons no one could explain, the switch stopped working.
The only thing they could do was immediately replace that piece of superfluous software and make it a company rule that one was allowed to add software, but you were never allowed to take something away.
For Dijkstra, that's a frightening situation. It means something is happening that you don't understand, which means, for all you know, a change you made in the software last week may cause the system to collapse 2 months from now. Dijkstra is a mathematician, and he believes in the tools of mathematics. Every important computer program, he says, is really like a long scientific formula, and you can use mathematics to prove that it is correct, that it gives you the correct answer under all circumstances. This is the formal methods approach to software. It's rigorous, takes a lot of time, and requires highly trained people. Some people say the idea of using it on something as huge as the telephone system is ludicrous. Dijkstra says the people who make that argument are fools. People have used formal methods to create highly reliable software, but mainly in Europe. They've never really caught on in the U.S. Dijkstra, who's Dutch, blames that on American culture. Americans don't appreciate mathematics, he says. They're sloppy in details, and they're always in a hurry. They'd rather just try something out first and try to fix whatever problems come up later. David Fisher of the National Institute of Standards and Technology says it is a cultural difference.
But the point is, we succeed in areas where, by any reasonable logic, says it's not possible to succeed.
Again, take the phone system, Fisher says.
There are known to be bugs in the telephone system. And furthermore, bugs that are potentially disastrous.
A phone conversation takes up space in a phone switch's memory. Sometimes when people hang up, the switch fails to reclaim that memory, so it just sits there unused. That means phone lines do too, and before long, all the phone lines could be sitting there idle while customers get busy signals.
Where these bugs are arising from is not known.
This happens?
Yes, this happens all the time. However, clever solution. You have something that's called a daemon, which is just a kind of a autonomous software process going on in the background that runs through the system and looks for memory that is in this state and gives it back. And so even though we haven't found the source of the problem, and although the bug is still there, we end up with a very reliable system.
It's a typically American solution, Fisher says.
It's the sort of thing that a mathematician, a Dijkstra, would find absolutely appalling. But we're successful at it.
Does that mean we run the risk of the catastrophic bug out there somewhere that we never quite caught?
Sure. It's certainly the way we build software in America today.
But the way we build software in America today is changing. Discipline and order is replacing trial and error. Structure is placing boundaries on individual creativity. AT&T's Lee Stetcher.
We're beyond the stage right now where one person can go out there and hack a little piece of software together and provide any of these capabilities. We're way beyond that, by the way.
Frank Lanza, who's president of the Loral Corporation, has been in charge of complicated software projects for the Pentagon. Last year, he took on the job of building new software for the nation's air traffic control system.
Management is the first important ingredient for success. After luck comes management.
Some companies, including AT&T, have started moving in the direction of adopting Edsger Dijkstra's formal methods. Not to check the whole program, but at least to make sure the overall structure is sound. They've started reading sessions where programmers sit down and just read through the lines of code together, looking for typos and small bugs. Experiments show these editing sessions actually catch more mistakes than a lot of testing does. Down the road, many software developers hope they won't have to build huge programs from scratch anymore, but piece them together using a library of standard parts, well-tested sub-programs that can be used over and over again in many different programs. The idea is it would make the software business a little like the hardware business. Computer makers make their products out of standard chips and disk drives and cables, and general contractors build houses out of standard doors and 2x4s and pipes. The hope is software built out of standard parts will be as reliable and as stable as houses are. This is Dan Charles reporting.